There are three parts to 7E. There's counting, there's permutation, and then there's combinations. So this first PowerPoint is counting and permutations. And so counting is making arrangements with repetition or with replacement. So think in terms of the AND probabilities that we had done. So these would be independent events where one is not relying on the other. And so we're going to be able to repeat or replace the item that we picked out. So think about it in terms of license plates. We have about 7 million or so Arizonans, and do we have enough license plates? So originally, license plates came in 6 spots, and so and in those 6 spots we had letters here. So these ones were letters, and then these ones were numbers. And then they reversed them, and then they put numbers first, and then letters afterwards. And so, and we could repeat letters, except for, there's a couple of combinations here and there that can't be done. But letters first, and then numbers. So there's 26 possibilities for the first one. I can reuse the letters, so another 26, and so on and so forth. So I get 26 times 26 times 26. Remember, these are these are independent, so we're multiplying, times 10 times 10 times 10. And then when we reverse them, we get 2 times that amount. So we have over 35 million possible license plates that could have been made with the 6 spots. But we now have 7, and in those 7, the first 3 are letters, and then the next 4 are numbers. And so right now we have 26 times 26 times 26 times 10 times 10 times 10 times another 10. So this would be 175,760,000 possible license plates that could be made. So it seems like we have plenty, but keep in mind that many people have multiple cars, businesses, and so forth. So there's lots of need for those license plates, and then once it's made, it cannot be repeated. All right, same thing with area codes. We had 602 originally, then in 1995 we broke up the 602 to just the Phoenix area, and then everything else was 520. And then we broke up 520, or actually we broke up 602 and broke it up into 623, 480, and 602 in the Metro Phoenix area. That was in 1999. And then 2 years later, they broke up the 520 into a 928 and 520. And there's talk to have Tucson have its own 520, and then everything else in the southern Arizona have its own area code as well. So it's possible that we will have 6 area codes in Arizona not too long from now. So how many possibilities, arrangements do we have? So we know just without the area code. So we have 3, and then we have 4 more here. And so the first number cannot be a 0. Possibly cannot be a 1. Cell phones can have a 1, but a landline cannot. So there's 9 possibilities here, and then 10 everywhere else. So we have about 9 million. Some people might say 8 million, just depending on whether or not you want to get rid of the 1 as well there, but you definitely can't have a 0 there. So then, permutations are a special kind of arrangement where now it's still an independent event, but now it's without replacement. So it's still a AND event, and it's not independent. Now it becomes dependent. So it's without replacement. So it's like the M&Ms. Once you eat an M&M, you're not going to put it back in. And so my analogy for permutation is ice cream cones, because we want the order of how the ice cream goes on the cones to be specific. So we want to dictate what that order is. So the order matters, and we cannot replace once we put a flavor, if you will, on our cone. So if we have 3 scoops of ice cream, and we are not allowed to order the same flavor, so we only get 3 flavors, so vanilla, chocolate, and strawberry, these are the possible ways to put them on our cone. Okay, and so again, we have 3 spots. There are 3 ways to pick out the first one, either chocolate, vanilla, or strawberry. Once that's picked out, we only have 2 ways to pick out our last, and then our last one we only have 1 way, and so we have 3 times 2 times 1, which is 6, also known as 3 factorial, so that's an exclamation point, okay, which is called a factorial. So then we also have, so on our calculators, we can find this button. It's going to be under the math key. And then you're going to go right arrow over. Okay, so we have math. So your math key, clear that out. So math. And then you're looking for probability, so you arrow over till you get to probability. And then you'll see number 4 is the factorial. Some of these might be different depending on the calculator you have. So we're going to start with the number that we want. So we're going to do 3, and then the math key, right arrow over till you get to probability. And then you're looking for the exclamation point. So I'm going to do 3, math, and then over to the probability. And then number 4 in my calculator is the exclamation key, and enter, and it gives you the value of 6. So that's not, it's 3 times 2 times 1. Sometimes we'll get numbers that are really large, and so using the calculator function is much easier if you have large numbers. And so now, to finish that, we would hit the enter key after we find whichever one is. It's either 3 or 4 depending on the calculator that you have. So 5 different books are on a shelf. And how many ways can we arrange them? Well, we have 5 ways for the first one, 4, 3, 2, 1, so my answer is 5 factorial. There are 6 permutations, 6 factorial permutations of the 6 letters, so we're not trying to make a word, we're just rearranging these. And how many of these is R the second letter? So if I already use R, then that means there's 5 letters left, and then 4, then 3, then 2, then 1, so this answer is also 5 factorial. How many of them are Q and E next to each other? Okay, so if I put Q and E in the first spot, so that's kind of taken up, so that means I have 4 letters, and then 3, then 2, then 1, so I have 4 factorial there, but I can move Q and E to the second and third spot, which still means I have 4 times 3 times 2 times 1. I can move Q and E again. I can move Q and E to first to the last spot, and then one more time. So they can be in the last spot. So I have 4 factorial times 1, 2, 3, 4, 5 different ways of doing that. But then Q and E can be the opposite of each other. Instead of Q and E, I could have E and Q. It doesn't have to be in that order. So then I'm going to multiply that by 2. So my answer is 4 factorial, 4 times 3 times 2 times 1. There's 5 different positions, and then I could switch the order times 2. And this one, how many different arrangements? So if we're talking about arrangements, that's replacement. So I have 1, 2, 3, 4, 5. So I have 5 digits, so I can put 5 there, 5 in each one of them, because we're talking about an arrangement. So I end up with 5 raised to the 5th power. How many 5-digit numbers can you make of the digits as a permutation? So now this is without replacement. And so, and 0 can't happen. 1, 2, 3, 4, 5. So that means I have 4 possibilities for the first one because we can't have a 0 here. Now that I've put a number here, I have 4, and then 3, then 2, then 1. So I have 4 times 4 factorial. Okay, and I'll let you guys figure out the odd one. A different type of permutation is if you're not going to use all of the items. So let's just say that we want to use 4, let's say there's 4 kinds of ice cream, but you only want 2 scoops. So instead of using all of 4 scoops, we're going to only use 2 of them. So the notation changes, and now you have 4p2, which is going to be in your calculators as well. And suppose we have a swim team that has 4 people on it, and we want to select 2-person relay team from them. So, or another one is we have 4 people running 2 positions, president and vice president. So those are all the different ways to create those. And in our calculator, we're going to do 4, and then go to the math button again, go over to probability, and you'll see that in this case number 2 is my choice, and then I'm going to choose 2, and so I hit enter, and my answer is 12. So again, your calculator can do the work for you in terms of finding out that answer.